Hi everyone, this video is not necessary for you to watch. It's really just more of a review from the Desmos activity in case you either need a little bit more explanation on things or in case you missed class. So if you have your pink packet, these notes will be on pages 3 and 4 in your Unit 1 packet. So our learning targets are I can graph a piecewise function and I can evaluate function values using a given piecewise function or the graph of a piecewise function. So by the end of this video, or really by the end of the Desmos activity, you should have been able to do both of those things. So we're going to start out by looking at graphing. Graphing piecewise functions. So we've got this function f of x, and it's 2x for x is less than or equal to 2. It's 4x minus 4 for when x is greater than 2. So before we even start to graph, we have to ask ourselves a couple of questions. So the first question is, how many pieces should this graph have? So the answer to this, hopefully you guys already know, is that there are 2 pieces to this graph. We know that the breaking point is at x equals 2. And the reason that we know that there's 2 pieces and where the breaking point is we look at the break in the domain. One piece, this 2x, is only for when x is less than or equal to 2. The other piece, this 4x minus 4, is for when x is greater than 2. So we know that the breaking point is when x equals 2, and there's those 2 separate pieces. So one strategy for creating your graph is to make a table. This is not the only strategy that you can have. So please don't think that I'm telling you you have to make a table. It's just that I think people kind of forget that we can do that. So we're going to make a table for the first piece of the graph, which is 2x. So we're going to do x, and we're going to do f of x equals 2x. And I know that I want x values that are less than or equal to 2. So the highest x value that I'm going to have is 2. So I'm going to go ahead and just do 1 and 0 also, because that's nice and easy. So if I plug in 0, I get 0. If I substitute 1 in for x, I get 2. If I substitute 2 in for x, I get 4. Since my domain tells me that x is less than or equal to 2, I know that at x equals 2, I'm going to have a closed circle on this portion of the graph. So I'm going to go ahead and actually graph that. So 2, 4 is going to be a closed circle. And then I know the point 1, 2 is right here. 0, 0 is right here. And this is just a line, so I'm just going to connect them. That was not straight, sorry. And draw an arrow because this is going to keep going for all x values to the left here. Then for the next one, I'm going to do x. I'm going to do now f of x is equal to 4x minus 4. And now I know that my smallest x value is 2, and it's not going to be equal to 2, so I'm going to have an open circle. So if I go ahead and plug in 2, 4 times 2 is 8, minus 4 is 4. And then, excuse me, I can pick 3. So 4 times 3 is 12, minus 4 is going to be 8. And that's not even on here, but that's okay. So I'm going to have an open circle at 2, 4. Well, hopefully you notice that that's actually where this green circle is already filled in. So I'm going to put the purple one around it just in case. But we can see then that this is actually going to be connected here. And then let's see, 3, 8. So 3, if this is 6, 8's probably going to be somewhere up here. And so I'm going to go ahead and just connect that and go through it. So we can see that this happens to be 2 separate lines that are actually connected, and they just have separate slopes. Now we're going to talk about evaluating piecewise functions. So remember, evaluate just means you're figuring out what the function value is. So the first part here asks us to evaluate f of 2 using the equation. Well, since this portion of my graph is where x is equal to 2, then that's the piece I'm going to use to evaluate my function. So f of 2 is going to equal 2 times 2, which is 4. So you have to look for the correct piece of the piecewise function and use it. So I know that this isn't on here, but just as a quick example, if I wanted to figure out, say, f of 5, then I need to look at where in this piecewise would x equal 5. That would be on this second portion here, which means that's where I'm going to plug in the 5. So I would do 4 times 5 minus 4. So I get what? 20 minus 4 is 16. So just as a quick example, you just have to pick the correct piece. Then if we're evaluating f of 2 using the graph, it means where is there a closed circle for x equals 2. So x equals 2, there's a closed circle right here at 4. So f of 2 from the graph is also 4. We're going to use the following equations to find f of 2 pretty quickly here. So for the first one, f of 2, we want to know where is it. X equal to 2 is going to be in this first portion here. So we're going to do f of 2 is equal to 2 times 2, which is 4. For the second one, we can notice it looks like a very similar piecewise function, but the second piece of the graph is a little different. But we're again looking for where x is equal to 2. So we're going to do f of 2 equals 2 times 2, which is 4. For question 3, if we're looking at where x is equal to 2, that's going to be right here. So f of 2 is equal to 4. We don't even have to actually plug anything in, but hopefully we can recognize right away that this third piecewise is totally different from the first two because it now has 3 pieces. Question 4 is also a 3-piece piecewise function, but we're looking for where x is equal to 2. So f of 2 is going to equal 4. And for number 5, if we look at these, at the break in this domain, one is for when x is less than 2. The other piece is for when x is greater than 2. There is no x equals 2. So for this one, f of 2 does not exist. So what do we notice? Well, for the first 4, f of 2 is equal to 4. So even though these are all separate piecewise functions and they would look totally different if we were to graph them, we can tell that the function value at 2 is the same for those first 4. So that's a little strange. Let's take a look at these graphs. I'm going to go ahead and highlight really quickly. We're going to be looking at the graphs as we get closer and closer to x equals 2. So at x equals 2, we're looking right here at this graph. We're looking here at this graph, here, here, and here. Now, if you're really good with your graphs, you'll actually notice these are the 5 functions from up above. So question 1 here is this first graph, and then so on with the rest. So you'll notice in the first one, it looks like we're approaching 4 from both sides, right? If we look at here and here, even though these are 2 separate pieces, they both look like they're going to the same place, which is cool. If we look at this one, though, we can notice there's a break. From one side, it's getting closer to 4. From the other side, it's all the way up at 5 now. Now there's this jump. So if you look at the rest of them, we notice kind of a similar pattern. Even though all of them have the same function value for those first 4 anyway, all of them have a function value at 4, but the graphs look totally different. And then for graph number 5, there is no function value at all, but it still looks really similar to graph 4 and even graph 1 a little bit. So we kind of have to be careful about what's happening and what's going on around function values, not just specifically at the function value. So we're going to talk just really briefly here. As you can see, evaluating a function is not enough information to give us a complete picture of what's happening. We need a new mathematical tool to communicate the, sorry, hold on, I got to get a color here, behavior of a function near an x value. This should be an, not and, sorry. So we need a new mathematical tool to communicate the behavior of a function near an x value. This tool is called a limit. So we're going to be looking at what's going on around that x value, not just at that x value. So again, we did that in the Desmos activity. Hopefully this helped clear it up even just a little bit more. And you guys are going to be watching the lesson 2 video for homework to help dive even further into limits.